Question 11 says if s is equal to the square root of t squared minus 4t plus 4, find t in terms of s. So I rewrote it here for clarity, and then I've circled this part because here you'll have a square root. That's kind of hard to work with if you're trying to get t to be by itself. So what I did was I squared both sides. So now I have s squared is equal to t squared minus 4t plus 4. Next, I noted that this quantity here, this t squared minus 4t plus 4, is a difference of squares. So I split it into t minus 2 times t minus 2. And so my next step would be to get t by itself. So I would say I would add 2 to both sides. So now I have t is equal to s squared plus 2. And that's twice because of the square root that happened earlier. So that's your option for B. Question 12 says if x minus 4 is a factor of x squared minus x minus k, then k is, and it wants us to solve for k. So the first thing that we want to do is set x minus 4 equal to 0, because it's going to be a factor of this equation that they give us. So after we set x minus 4 equal to 0, we'll find that x is equal to 4, and then we want to substitute. So since we know that x is equal to 4, this x squared becomes 4 squared minus 4 and the minus k, because we don't have anything to substitute k for. We set this equal to 0, and then we solve for k. So 4 squared is 16, minus 4 is 12, minus k is equal to 0, and so we get that 12 is equal to k, which is your option for answer D. Question 13 says that the remainder when 6p cubed minus p squared minus 47p plus 30 is divided by p minus 3 is, and it wants us to solve for the remainder. So the first thing we need to do is do the division. So I've written out what they said here, and so the first thing I've done was I said how many times does p go into 6p cubed. So what I did was I said, well, that's 6p squared, because if I take 6p squared times just p, I will find myself with the answer 6p cubed. And that's what I was looking for. So the next step to do after that is I write it up here. And then I say, what is 6p squared times the quantity p minus 3? And then that's how I ended up with this part. I had this part will be 6p cubed, and then this will be negative 18p squared. So that's what I did. And then I've subtracted these. So 6p cubed minus 6p cubed is 0. Negative p squared minus 18 minus negative 18p squared is positive 17p squared. So now I start over with the process. I say how many times does p go into 17p squared? That's just 17p. And then I said, what is 17p times the quantity p minus 3? So I get 17p squared minus 17 times 3 is 51, so 51p. And then I subtracted. And so you'll notice what I did was I brought these numbers down. And that's what you're supposed to do in division. And so then I wrote an extra minus 0 here because there's nothing for this spot when I subtract, and it just kept things clearer for me. So I did my subtraction. 17p squared minus 17p squared is 0. Negative 47p minus negative 51p is negative 4p. Plus 30 minus 0 is just 30. And so now I'm left with p into positive 4p would just be 4. And so I take 4p minus 12, which is what I got down here. 4p minus 12, and I did my subtraction. And so remember, I'm subtracting a negative here. So you add, so you get 30 plus 12 is 42. Obviously 4p minus 4p is 0. So I get 42, and that's my remainder. Remember that the question that they were asking is, what is the remainder? So this is my answer, 42. Question 1 says, P varies injointly as M and U, and varies inversely as Q. Then it says, given that P is equal to 4, M is equal to 3, and U is equal to 2 when Q is equal to 1, find the value of p when m is equal to 6, u is equal to 4, and q is equal to 8 bits. So the first thing that you want to do is you want to make an equation or a formula given that first sentence. P varies jointly as m and u, and varies inversely as q. What they mean there is that P varies jointly as M and U. So M and U are here at the top because it varies jointly. So P times MU. That's how they vary with each other. But it varies inversely as Q, meaning that you need to divide P by Q. So I've just made these into a fraction. MU over Q times P. Then it says that given that, and then it gives us these numbers for our variables, and it wants us to find the value in of P when we have these variables. So first we're going to say that there's a missing factor when the numbers change. So I've added this extra K in here so that I know what this missing factor is. So I'm doing the first one, this first line. Given that P is equal to 4, M is equal to 3, U is equal to 2, and Q is equal to 1. So I just plug in all those numbers. So now I have P, I have M, U, and Q. And I'm leaving the K there so I can figure out how these numbers all change together. So then that means that K is equal to 4/6, which reduces to 2/3. Lastly, the final question that they ask us is find the value of P when M is equal to 6, U is equal to 4, and Q is equal to 8 fifths. So keeping my value of K in here, I plug in my other values, and then I start to solve for P. So 3 reduces to 1, and 6 reduces to 2, and I'm left with 2 times 4 on the numerator over 8 fifths. So that's 16 over 8 fifths. And then I can separate that out, 16 over 1 times 5 over 8, because remember that when you divide by a fraction, you can multiply by its reciprocal. And this reduces to 2, this reduces to 1. So now I'm left with 2 times 5 over 1, which is 10, and so your answer is A. If R varies inversely as the square root of S and T, how does S vary with R and T? So R varies inversely as the square root of S and T. So this inversely lets me know that something is going to be underneath the number 1. So 1 over R is equal to the square root of S times T. So I came up with that because R varies inversely as the square root of S and T. So let me, here. So square root of S and T, that's this part. R varies inversely with this. So that means 1 over R is equal to the square root of S times T. That's how I came up with this part. Next, they say, how does S vary with R and T? So the next step I need to do is to solve for S. So what I started to do was I took the square of both sides so that I could get rid of the square root. Now I have 1 over R squared is equal to S times T. Take it one step further and I'll have S is equal to 1 over R squared times T because I divided by T on both sides. So now here I am at this point. And so remember they're asking how does S vary with R and T. So what I need to do now, because they want R and T to be alone essentially. So what I did was I took the reciprocal of both sides. So now it's 1 over S is equal to R squared times T. So what is this saying? This is saying that S varies inversely as R squared and T. Because R squared and T are together, and S varies inversely with it because it's inverted. And so that's your option D. Question 16 wants us to evaluate this inequality. And so we have 3 times the quantity x plus 2 is greater than 6 times the quantity x plus 3. So what I started out by doing was just multiplying out these numbers. Oops, not there. There. So now I have 3x plus 6 is greater than 6x plus 18. So now I'm going to get x on one side. So what I did was I took this and I subtracted it from both sides. So it's gone here because 6 minus 6 is 0, and over here 18 minus 6 is 12. So now I have 3x is greater than 6x plus 12. Then what I did was I took this and I subtracted it from both sides. 6x minus 6x is 0. 3x minus 6x is negative 3. So now I have negative 3x is greater than 12. Lastly, I divided by negative 3. And remember that when you divide or multiply by a negative number with inequalities, you have to flip the sign. So now it's x is less than negative 4, which is your answer A. Question 17 says the graph above is correctly represented by, and you're supposed to choose the correct answer. So this is a parabola, it has zeros at negative 1 and 2, and it faces concave up. So how did I figure all that out? Well, it has the general shape of a parabola, but also I can see here clearly that it has this point remember points are in x comma y form, so it's negative 1 comma 0, and it has again over here another one where it's 2 comma 0. So it had zeros at negative 1 and at 2, and it's concave up. That's this general shape. That's what we call this, concave up. So the equation for a parabola will look like any one of these, essentially. So it has x squared, then x, then a number standing by itself. That is derived from one of these, where you have two quantities of x to the first power of some sort, well, x to the first power plus a number of some sort, multiplied by a similar looking quantity. So normally what we would do if we were asked to find the zeros is we'd be given an equation like this, and we'd have to split it up, and then we'd solve for 0 by setting these equal to 0. So I would say x plus 1 is equal to 0, and then I would get x is equal to negative 1, and that would tell me that it was a 0. But we can already tell what the zeros are from the graph, so we can work our way backwards. Now that I know that one of the zeros is negative 1, I can work my way backwards to this point where I have x plus 1. That's where I got this part from. I can do the same thing with this too. Because my final answer was x equals 2, that means that up here, when I set it equal to 0, this was x minus 2. And so that's how I got this part. Then I multiplied this out, so now I have x squared minus 2x plus x minus 2. And then that leaves me, once I simplify, with x squared minus x minus 2, which is option C. Question 18 wants us to solve for x, and it says that the absolute value of x minus 2 is less than 3. So because this is an inequality, we can essentially ignore the absolute value sign and just drop it off. So now we have x minus 2 is less than 3. So then I would add 2 to both sides, and I have x is greater than 5, which is option C. Question 19 tells us the sum of the first two terms is 3, and the sum of the second and the third term is negative 6. Find the sum of the first term and the common ratio. So I've written a few things out just to get a clear idea of exactly what it is that they're asking. Right, so first I labeled off GP, stands for geometric progression, which means that the numbers in this progression will be increasing by a certain factor. And this could, be going up by multiplication or division. And then I've listed out x, y, z. Those will be your first three terms, right? And what they're saying is that the first two terms add up to 3, and the second two terms add up to negative 6. I've written out what that means, like just represented by letters. And then I broke down what it is that they want us to find, right? They said find the sum of the first term and the common ratio. So just remember that those are two different things we're trying to find, and at the end we have to add those things up, and that'll give us our overall answer. And I've just labeled that the common ratio is going to be the factor that everything changes by. So first we're starting off with this equation. So this equation right here is the equation that you would use for the sum of consecutive terms in a geometric progression. So knowing that they said that the first two terms add up to 3, we're going to use that. basically the sum number of terms, right, is going to be equal to the first term a times 1 minus r, where r is the common ratio, to the n over 1 minus r. This is term 2 written out, and then I have plugged in the values that they gave us. They told us up here the sum of the first two terms is 3. So since it's the first two terms, then r is going to be squared. 1 minus r squared can be factored out into 1 minus r times 1 plus r. So that's helpful. And then from there, we can simplify, right? So 1 minus r on top here cancels with this on the bottom. And we're left with 3 equals a times 1 plus r. So that's our first equation. And then now we're going to use the equation for an arithmetic progression. We have here the second term. Well, here's the overall equation. So the second term is going to be represented by this, right? Because n is 2, and we plug that in up here, so 2 minus 1 is 1. So that's our second term, and then our third term is going to be represented by this equation, and I've plugged in the 3 for n instead. And then they told us that the second term added to the third term is equal to negative 6. So a2 plus a3 is going to equal to negative 6, and these being equal to a2 and a3 added up will also be equal to negative 6, so I set them equal to each other. a2 plus a3 is negative 6, and then we just go ahead and simplify, and you see I've pulled out a 1 plus r here, and you'll see why that's useful in a moment. But this is my second equation. And then they want us to find the common ratio, right? That was part of the original question, find the first term plus the common ratio. So for the common ratio, I'm taking equation 2 and dividing it by equation 1. Here's my equation 2. Up here was equation 1. So I do that, and now I've solved for r, and I found that r is negative 2. So that's part of the answer, and they want us to know what the sum of the common ratio and the first term are. So to find the first term, and now that I know r, I can go back and plug that into the first equation, right? So I know r is negative 2 now, so 3 is equal to a times 1 plus r. And
plug in negative 2 into the equation. When you solve out, will be equal to negative 3. For the final step, we add the first term, to the common ratio, r, which is negative 2 plus negative 3, which is negative 5.
Question 20 wants us to find the nth term of the progression listed here. And so I'll start off with the denominator because I think that will be easier for me to explain and move on to the numerator. So with the denominator, what's happening? So it goes 2, 3, 4, 5. It's pretty easy to tell that it's just going up by 1. So, and it starts with 2. So the first term of the sequence, this term right here, the first term, that means that n would equal 1. So 1 plus 1 is 2, and I'm easily arrive at the denominator's first term. And then if I want to get the second term, I can plug in 2 plus 1 is 3, and so on and so forth. And all I have to do is add 1. However, up here at the top, you'll see that it's going up by 3. 4, 7, 10, 13. Not only that, but it starts off with the number 4. So how do I fix that? Well, first off, let's think how we can get there, kind of like we did down here. So this whole n plus 1 thing. How can we get it to work for the number 4 instead of the number 2? Well, you can say 3n plus 1, because 3 times 1 is just 3 plus 1 is 4, and we're there. And it turns out that this can continue to work because then the next number that you plug in, so 2 times 3 is 6 plus 1 is 7. 3 times 3 is 9 plus 1 is 10. So using this 3n out here easily advances you by 3 each time. And so yeah, so this is your answer. It's option B. Question